Hello everyone. Next we are going to discuss another transformation. Suppose f of x which is transformed to f of kx, and then we go for f of x which transforms to f of x divided by k. Here the value of k more than 0. Here the value of k which is more than 0. Let us observe these two transformations now. For example, there is a function y equal to sin x, and the transformation y equal to sin of 2x. Let us observe now. You know that the graph of sin x, that is a wave passing through origin in this way, in the limited boundary it is. This is the graph of sin x, 0, here it is pi, and it is 2 pi, at minus pi 0, at minus 2 pi also it is 0. Now you need to draw the graph of sin of 2x. Sin of 2x nothing but x multiplied 2 times. Here by substituting x equal to pi, the value of y become 0, but in this case if you write 2x equal to pi, that is x equal to pi by 2, then the value of y become 0. So the graph exists like this. At x equal to pi by 2 itself it becomes 0. Previously the graph 0 at pi, but now the graph 0 at pi by 2 only. So that, and also remember, sin x value, that is always lying between minus 1 and plus 1. The same way the graph of sin 2x also lies between minus 1 to plus 1. So there is no change in the range of the function, only the graph exists with the same range, and in advance it becomes 0 like this. This is the graph with same range will get, but in advance it becomes 0. Here at x equal to pi 0, but here at x equal to pi by 2 0. So that what you observed from these two figures means the graph shrink k units, right? Here 0 to pi you have U-shaped graph, but here 0 to pi by 2 you have U-shaped graph. Nothing but the graph shrink towards positive x as well as negative x 2 units. So here I am going to write the condition shrink the graph k units towards x directions. In both the directions you have to shrink the graph. Next, let us observe the transformation f of x to f of x divided by k. Suppose that y equal to sin x, y equal to sin of 1 by 2 into x. Again, standard graph of sin x first. In the limited boundary I am going to draw the graph. Here it is 0, pi, pi by 2, minus pi by 2, sorry, this is minus pi, and this is 2 pi, right? This is 2 pi. this is pi, and here it is minus 2 pi. Okay, this is the standard graph of sin x. Here the graph 0 at x equal to pi. At x equal to pi, y becomes 0. Next, here 1 by 2x. If x equal to pi, sin pi by 2 become 1. If x by 2 equal to pi by, not pi by 2, here 2x equal to pi. At pi it is 0. When input is pi, that becomes 0. But here input x by 2, suppose pi, then x become 2 pi, and at x equal to 2 pi, the value of y become 0 in this case. Let us observe, if you write x value 2 pi, what happens? 2 gets cancelled and we get sin pi, that become 0. So you will get the graph. The graph of sin of 1 by 2x now. First at 0 it is 0, and then at 2 pi it is 0. Next here it is minus 2 pi, and the range of the graph again same, from minus 1 to plus 1. Here you have to shrink the graph towards x directions, and here when you have 1 by k, stretch the graph. Stretch the graph k units. Towards x directions. So this is the way of transforming f of x to f of kx and f of 1 by k into x. Let us discuss different examples based on this. Suppose the question is, draw the graph of y equal to cos 2x. Next question, draw the graph of y equal to cos of x by 2. Here range of the function, due to cosine function, its range minus 1 to 1. Again cosine function, its range from minus 1 to plus 1. We are going to transform from cos x to cos 2x here, and here cos x to cos x by 2. What we discussed, whenever f of x transform to f of kx, you have to shrink the graph k units towards x directions. First, draw the graph of cos x. You know that this is the graph of cos x. Here it is 0, this one pi by 2, and here it is pi, and it is of 3 pi by 2. You have to shrink the graph towards x directions 2 units, nothing but you will get the graph in this way. At pi by 4 it become 0. You have to shrink the graph. So the graph exists in this way. This is the graph. Next, at pi by 4 it becomes 0. Next, at pi by 2 it become minus 1. Next, here this is the graph. Okay. Next, for pi it is minus 1, and here at pi by 2 after transformation it become minus 1, and then the graph exists in this way. You have to extend this like this. Next, cos x and cos x by 2. You know the graph of cos x. This one is the graph of cos x. 0, pi by 2. Here it is of pi, 3 pi by 2. Right? Now, you have to stretch the graph 2 units, and hence the graph exists in this way. Let us observe. When you write 0, cos 0, 1. When you write pi, cos pi by 2, cos 90, that is 0. Next here at minus pi it become 0. Here also let us cross check. When you write x value 0, cos 0, that become 1. When x value pi by 4 here, 2 pi by 4 nothing but pi by 2, cos 90, 0. And here also at minus pi by 4 it becomes 0. So this is the graphical transformation. Remember that when f of x changes to f of kx, just shrink the graph k units towards x directions. Next, when f of x transform to 1 by k, f of x transform to f of 1 by k into x, then stretch the graph k units towards x directions in this way. So this is about the transformation from f of x to f of kx and f of x by k. Next, let us move to the next transformation, that is f of x to k times of f of x. Next one, f of x to 1 by k times of f of x. Suppose if you have y equal to sin x, then how to draw the graph of y equal to some 2 times of sin x observe. And in the second case, suppose if you know the graph of y equal to sin x, then let us observe how to draw the transformation y equal to 1 by 2 of sin x. You know that sin x value always lying between minus 1 to plus 1. Here also the same I am going to write sin x value between minus 1 to plus 1. When you multiplied with 2, if you multiply with 2, what happens? 2 sin x, its maxima 2, minima minus 2. So that the range from minus 2 to 2 exists. Here by multiplying with 1 by 2, what happens? Maxima 1 by 2 and minima minus 1 by 2. You know the graph of sin x that exists in the interval minus 1 to 1. First draw the graph of sin x and then go for 2 sin x. Only in the interval minus 1 to plus 1, the range of sin x and the graph exists in this way. This is the graph in the limited boundary. Now when you have 2 sin x, nothing but its range from minus 2 to plus 2. That is the graph. As extends to 0, it is 0 only. but when you put pi by 2, sin 90 1, and it reaches maximum value 2. So in the previous case maximum value 1, now in this case maximum value 2. So you will get the graph in this way. Here minus 2 minima plus 2 maxima, minus 2 minima. Here the graph stretched along the direction of y-axis just 2 units, remember. Just stretch the graph k units towards y directions. In both the directions you have to stretch the graph. So this is the condition for transformation of f of x to k into f of x. And now here 1 by 2 sin x, first sin x graph, its range minus 1 to plus 1. In the limited boundary the graph exists in this way. When you have 1 by 2 of sin x, maximum value 1 by 2, minimum value minus 1 by 2, and its graph, in the previous case maxima 1, but now in this case 1 by 2. Here it is minima minus 1, but now minus 1 by 2. Here it is 0. Joining all these we get the graph in this way. This is the graph. So that what is happening here, the graph shrink k units in this way. The graph shrink k units towards the directions of y. So that I am writing shrink the graph k units towards y directions. So this is the logic behind this, and transforming f of x to 1 by k f of x. Let us move to the next one. Next transformation. The transformation of f of x to modulus f of x. Suppose there is a function y equal to log x. Then the transformation y equal to modulus of log x, observed by graphically. You know that the graph of log x that exists only for positive values of x in this way. Here it is 1, 0. When you have modulus of log x, it is very clear that logarithmic graph, some portion below x-axis and the other portion above x-axis, when you put modulus sign, the graph previously which is in the negative portion, that become positive. So that here what I am doing, the positive graph as it is, and then the negative graph I am going to reflect over x. Why? Because when you put modulus sign, the negative portion which you have previously, that become positive. So this is the graph of modulus log x. So that here I am going to write the condition, neglect the graph which is below x-axis, and you have to reflect it over x axis. So this is the logic behind transformation from f of x to modulus f of x. Different kinds of functions I am going to select. Suppose the question is draw the graph of y equal to modulus sin x, or suppose the question draw the graph of y equal to modulus x minus 1 into x minus 2. What happens? Observe. You are familiar with the graph of sin x, and from the graph of sin x to you have to transfer modulus sin x, and here a parabola x minus 1 into x minus 2. From this you have to transfer modulus of x minus 1 into x minus 2. This is the graph of sin x. If some portion below x axis and the another portion above x axis. Next here mod x minus 1 into x minus 2. Before going to draw that, first you have to draw the graph of x minus 1 into x minus 2. That indicates a parabola which is passing through x equal to 1 comma 2. This is the graph of second degree, right? When you have modulus sign, you have to neglect the graph which is entirely below x axis. That is the first rule. And then whatever the negative quantity, that become positive by applying modulus sign. So this one become positive and this also become positive, and the previous positive result as it is. So this is the graph of y equal to modulus sin x, remember. Next, you have to put positive graph as it is, and the graph which is negative, that you have to make as positive. Negative graph you have to make it as positive. So this is the graph of modulus x minus 1 into x minus 2. Let us move to the next one, next transformation. Suppose f of x transformed as f of modulus x. For example, if you have y equal to log x, then how to draw y equal to log of mod x? Observe. You know that the graph of log x, this one defined for all positive values of x, and here it is 1 comma 0. Log x is defined only for positive values of x, but here mod x you have except to 0 you can write any real number. Why? Because negative number if you write modulus, that changes the negative into positive term. So you have to give both positive input as well as negative input, but if you give negative input, again it should be positive, so that the same graph which you have for positive values, the same you will get left hand side. This is the graph for positive values of x. The same graph you will get for negative values of x. Why? Because if you write x equal to 1, here log 1 0. If you write minus 1, modulus minus 1 again 1. So for minus 1 it is again log 1 0 here. So the same graph you will get in the left side, so that you have to reflect the graph with reference to y-axis. And one more thing, if any graph if exists left part of y, that you have to remove. let us see that with another example. Here positive x, positive values of x, negative values of x gives the same output, so that the same graph which you have right side, that is reflected as left side. I am going to select another example. Suppose that the question is, draw the graph of y equal to modulus of sin x. You know the graph of sin x. This one is the graph of sin x in the limited boundary, right? Modulus sin x means the value of y greater than or equal to 0, but not negative, remember. So I am going to select the function as sin of mod x here, not modulus sin x. It should be sin of mod x. Why? Because f of mod x you have, yes, sin of mod x. This is the graph of sin x, right? Now sin of mod x is nothing but, that is sin x when x is positive. When x is negative, it is sin of minus x, right? So whatever the graph for positive values of x, that you have to draw as it is. So that this one is the graph of sin of mod x, which is equal to sin x when x is positive. But when x is negative, here we are going to apply the transformation f of x to f of minus x. F of x to f of minus x says that you have to draw the graph symmetric about y-axis. It is y-axis symmetry in this transformation. Why? Because if you write x value pi, it is 0. If you write minus pi, also it becomes sin pi becomes 0. So here, suppose if you write pi by 2, sin 90 value 1. If you write minus pi by 2, due to modulus sign, again that becomes sin pi by 2 1. So you will get the graph in this way. That is the same graph which you have in the right part, the same symmetric graph exists here with reference to y-axis. So the graph is y-axis symmetry. Just I am going to write here. First you have to neglect the left portion. Only the positive portion you have to write, and then you have to draw symmetric graph about y-axis. That is here the graph, the condition here. First you have to neglect the graph of f of x left side. Why? Because only the graph for all x more than 0, what you have, the same graph we are going to get in the left side. So this left side graph you have to neglect. First you have to neglect the graph of f of x left side, and second point, reflect positive side graph into negative side. This positive graph you have to reflect towards negative. So this is the transformation from f of x to f of mod x. Next, let us move to the next one. Suppose f of x, it is transformed to modulus of f of modulus x. First f of x, and then you have to draw f of mod x, and after that you have to draw f of mod x, right? Suppose for example the question is draw the graph of y equal to modulus log of modulus. In this case, first you go with log x and then draw log mod x, and after that put modulus sign to this log x graph. You know the graph of log x, this one. Next, log mod x. Log mod x graph. Just now we discussed about f of mod x. If the graph is left hand side, you have to neglect, and the same right graph you have to reflect in the left hand side, this one. Next, modulus of log of mod x, and for which we are going to apply modulus sign. That means the graph should be non-negative, remember. So positive graph as it is. Due to modulus sign, the graph is non-negative. The negative portion changes to positive. So this negative portion changes to positive. This one is the graphical transformation. So here when you have modulus of f of mod x, f of x transform to f of mod x, and then f of mod x transform to modulus of f of mod x. This is about graphical transformation, and these graphical transformations are helpful and they are interlinked with the topics limits, continuity, differentiability and applications of derivative, as well as they are useful in definite integrals and calculating area between two curves. So that that much of importance we have in graphical transformations. These are very important in entrance point of view. Thank you so much.